Okay, section 5.5, inequalities involving absolute value. We're going to review solving absolute value equations really quickly. Number one, can an absolute value ever equal a negative number? No. So anytime you have an absolute value equal a negative number, it is no solution. Now, number two, absolute value of x plus 2 is equal to 4. We take it out of the absolute value as is, put it equal to a positive 4, or take it out of the absolute value and put it to a negative 4. So we're going to have two equations. Subtract 2 on both sides, so that's x is equal to 2. Subtract 2 on this side, and x is equal to negative 6. So x is equal to 2 or x is equal to negative 6. Now look at number 3. By glancing at it, it looks like the absolute value is equal to a negative 1. But is that the case? No, remember the absolute value has to be by itself. Is the absolute value by itself? No, it's got that minus 7, so we've got to add 7 on both sides. Now let's rewrite it to say absolute value of 3n minus 4 is equal to 6. Okay, now we can solve this. So we take it out of the absolute value, 3n minus 4 is equal to 6, or 3n minus 4 is equal to a negative 6. We have two equations to solve. So that's 3n is equal to 10. Divide, so n is equal to 10 thirds. On the other one, add 4. 3n is equal to negative 2. Divide, n is equal to negative 2 thirds. We do not have to turn these into mixed numbers. We would have to turn them into mixed number if we were graphing. But leaving it as 10 thirds is just fine. Okay, example 1. Solve each inequality, then graph the solution set. When we have an absolute value is less than 11, we treat it just like if it's an equal sign. We take it out of the absolute value, m plus 2 is less than 11. The only difference is we are going to use the word and. Take it out of the absolute value, and when we go to put it to the negative 11, we have to flip the symbol. We flip it to negative 11. Don't forget to do that. Anytime when you go to put it to the negative, you flip the symbol. Okay? Now we have two equations. We're going to solve each one. So that's m is less than 9. Over here, subtract 2. Alright, so m is greater than negative 13. Now, bring down the and. Do y'all remember what happens when we have an and? So think back to the last section. When we had two equations formed by the word and, we had to go one step further and put m in the middle. What do you put on each side? Less than signs. Smaller number on the left. Which is smaller, 9 or negative 13? Negative 13. Look, it's pointing to negative 13. It is still pointing to negative 13. It's open to the 9. It is still open to the 9. So how would we read this? M is between negative 13 and 9. So to graph it, okay, so it's going to be an open circle at negative 13, open circle at 9, and everything in between. Now, oops, sorry. I'm going to show you another way of doing this. This is a shortcut. So write the problem down a second time. Absolute value of m plus 2 is less than 11. Notice that the final answer was an in-between where we had m in the middle and less than signs on both sides, and the graph came in together. Well, And that's only for less than. So the shortcut is we can take what's in the absolute value, put it in the middle, put less than signs on both sides, put the smaller number on the left, which would be the negative 11 on the left, and the positive 11 on the right. Now, this is a review of 5.4 where we're going to get m by itself, so we're going to subtract 2 on both sides. And we get negative 13 is less than m is less than 9. Now, is this the same thing that we got, the first, right here? Could you do either way? Absolutely. And the graph would be the same thing. Negative 13, 9. Okay. Now, that only works for less than. Okay, example 1b. Absolute value of y minus 1 is less than negative 2. What numbers are less than negative 2? All negative numbers, right? Negative 3, negative 4, negative 5, and so on. Can an absolute value equal a negative number? Can an absolute value equal a negative number? No. So when you have an absolute value is less than all negative numbers, the answer is no solution. An absolute value can never equal a negative number. Okay, example 1c. Absolute value of n minus 8 is less than or equal to 2. We could do it the long version, or we could take it's a less than, which is an and, which means it's going to come in together where we're going to have the variable in the middle. So I'm going to go directly to I'm going to do the shortcut. Take it out of the absolute value, put it in the middle, and what do I put on each side? In this case, it'll be less than or equal to the negative 2 on the left and the positive 2 on the far right. Now solve, what do? We add 8 to both sides, to itself, on the far right and on the far left. Negative 2 plus 8 is 6, less than equal to n is less than equal to 10. And there is the answer. To graph it, it'll be closed circle at 6, closed circle at 10, and everything in between. Example 2a, read the word problem. A recent survey showed that 65% of young adults watched online video clips. The margin of error was within 3 percentage points. Find the range of young adults who use video sharing sites. Within 3 percentage points, that means it could be up to 3 ahead or 3 behind. So within 3%, so it could be 3 behind the 65, so it could be what? 62 all the way to what? 68. So the margin of error could be anywhere between 62 and 68, and including 62 and 68, correct? That would be the range. Do example 2b. The melting point of ice is 0 degrees Celsius during a chemistry experiment. Jill observed ice melting within 2 degrees Celsius of the measurement. Write the range of temperatures that Jill observed. So what would the range be? From -2 to what? +2. So if the temperature was anywhere between and including both -2 and 2, it starts to melt.
What was the one before that?
Absolute value of 3n plus 6 is greater than or equal to 12. Now, less than was an and, greater than All right, less than or equal to, we use the word and the graph came in together like this. When we have a greater than or or equal to, it's an or. Now think back to 5.4. What did an or look like, the graph? They went in opposite directions. Okay, so just kind of remember about that. Okay, so we're going to take it out of the absolute value. 3n plus 6 is greater than or equal to 12. But what word are we going to use? Or 3n plus 6. And when we go to put it to the negative 12, we do the same thing. What do? Flip the symbol when we put it to the negative. Okay? Don't forget, when you go to put it to the negative, we always flip the symbol. And if you do it the long version of and, you flip the symbol. Okay? Do y'all understand what I'm talking about by long version? Okay, now we have two equations. We have to solve each one. So we're going to subtract 6 on both sides. So that's 3n is greater than or equal to 6. Divide by 3. N is greater than or equal to 2. Subtract 6 on the other equation. It's 3n is less than or equal to negative 18. Divide by 3. N is less than or equal to negative 6. Bring down the word or. Do not forget to bring that word down. This is your answer. Remember, ors are two separate equations. We cannot put in a combined inequality. We have to graph. And they better be going in opposite directions. Close circle at 2, and n is greater than or equal to 2, so it goes to the right. And n is less than or equal to negative 6, close circle at negative 6, and it goes to the left. So always the ors are going to be going in opposite direction, and that's always the case for the absolute value. Absolute value 2k plus 1 is greater than 7. So this is a greater than symbol, so what goes with greater? Or. So we're going to take it out of the absolute value. 2k plus 1 is greater than 7. What word? Or. 2k plus 1. And when we go to put it to the negative, what must we do? Flip the symbol and put it to negative 7. Now we have two separate equations we're going to have to solve by subtracting 1. 2k is greater than 6. Divide by 2. K is greater than 3. Over on the right, subtract 1. 2k is less than negative 8. Divide by 2. So k is less than negative 4. And make sure you bring down the word or. This is your answer. They better go in opposite directions when we're graphing. So let's graph. K is greater than 3, open circle, and it goes to the right. And k is less than negative 4, open circle, and it goes to the left. Okay? Example 3c. Absolute value of r minus 6 is greater than negative 5. Now, let me back up for just a minute. Remember, if it was r minus 6 is less than negative 5, what numbers are less than negative 5? All negative numbers. What was the solution? No solution. Well, r minus 6 is greater than negative 5. What numbers are greater than negative 5? A few negatives, but then the rest are all positive. Can an absolute value equal a positive number? Yes. So when you have something like this, that would be all real numbers. Okay? When you have an absolute value is greater than a negative number, the answer is all real numbers. When you have an absolute value is less than a negative number, it's no solution. Did y'all write this down? Write an open sentence involving absolute value for each graph. Open sentence means write the absolute value. It's like the question. So we see the final answer. We see the graph. And for example, 4a, it's numbers between -2 and 2. What is right smack in the middle? What number is in the middle of this graph? 0. It's always going to be an absolute value. First, is this a less than or a greater than? Remember, when they come in together, they're what? It's a and, which is a less than. So I know it's going to be a less than. Is it going to be less than or equal to, or just less than? Less than, because it's open circle. So inside the absolute value, it's always going to be x minus the number. So it's x minus, what is the middle here? 0. So x minus 0. Well, what is x minus 0? In this case, it could just be x. Now, so its absolute value of x is less than, from the middle, how many places did we have to go to the right? 2 places. How many did we have to go to the left? 2 places. So the distance is what? 2. So in this case, its absolute value of x less than 2, because the middle was 0. Let's look at example 4b. They're going in opposite directions. What graph goes in opposite direction? An and or an or? An or. And what inequality goes with or? A greater than symbol. So it's some absolute value. So let's find the middle. Is 5 the middle? No, what's the middle? 5.5 is the middle. 5.5 is the middle. Because we went a half, and then 1, 2, 3, 4. So we went over 4.5 on the right. On the left, here's a half, and 1, 2, 3, 4. So 4.5. So what is it going to be greater than or equal to? 4.5, because we went 4.5 places. Now, it's always inside the absolute value. It is always x minus the middle number. What is the middle number? 5.5. So it's x minus 5.5. Example 4c, is this an and or an or? It's an and what word goes with and? Less than. So I know it's going to be an absolute value is less than. Is it going to be less than or equal to or less than? Less than, because it's an open circle. So what's right smack in the middle? 5. So here's the middle. So it's always x minus the middle. So we would put x minus 5. Now from the middle, how many places did we have to go to the right? 2. And how many places did we have to go to the left? 2. So its absolute value of x minus 5 is less than what? 2. How could we check to make sure this is right? Solve it. And we better get that graph. Okay, let's look at example 4D. Is this an and or an or? Or, what word goes with or? A greater than, so it's absolute value of x. Now, what's in the middle? 5. So that will be x minus 5. And how many places did we have to go? 3. So it's absolute value of x minus 5 is greater than 3. Let's go back to those 2 word problems. Right here. If I asked you for the open sentence or the equation, what would this one be? What's the middle? 0. So it's absolute value of x minus 0, or can we just say x? Is this a less than? Is this an and or an or? And, so is this a less than? And it's a less than or equal to what? 2. what would the equation be for this one? What's the middle? 65, so its absolute value of x minus 65 is less than or equal to what? 3. So what if we had, hold on, come up with the equation for this one. What's the middle? The negative 4 is the middle, so it's absolute value of x minus a negative 4. And how do you write minus a negative 4? Plus 4. And it's a less than or equal to what? 3. So there's the equation. So let's just do a really quick recap. When we have an absolute value is less than some number, what word goes with less than? And one way you can remember that is less than. That's how you can remember less than is an and. What if you had absolute value is greater than number? That's an or, and one way you can remember that is spell it, say it's great or. Instead of greater, great or. So what goes with or? Great or. What goes with and? Less than. That's how you can remember. And a less than, the graph comes in together like this, and a greater, the graphs go in opposite direction. And that is the end of section 5.5.